Welcome everyone to Lecture 14, Arm Control with the Baxter Simulator. Today we're going to start by learning how to actually run the simulator. Baxter Simulator has a great integration with both Gazebo and RViz. The whole code should already be installed in your system from Chapter 1 in our textbook. But if for any reason you cannot run the code in this part of our course, please find all the instructions at the referred link. In this chapter, we explore multiple layers of control levels with Baxter, including kinematics, joint space, and Cartesian space planning, and high-level action servers. To start the Baxter Gazebo simulator, we need to start by setting the correct environment for a robot using this shell script, baxter.sh. When using the real robot, you omit the sim argument over here, but if we're using the simulated robot, you need to include this sim argument. To learn more about this shell script, please look at the Rethink Robotics website for more instructions on how to set that file properly. In my system, I can show you how we're running the system. So first of all, in my ROS workspace right here, I have placed the Baxter shell script at this location. If you're just using the simulator and you do not have the real robot, really the only line you would need to uncomment would be this one right here, your IP address. And you can always set it locally to 127.0.0.1. That's about all you need to do to make sure that this script is running properly. After that, you can and one more thing is to make sure that this has an executable property. So you can always do that with chmod and then run it on the baxter.sh file, which I have already done. If you do that, then you'll be able to run this as an executable shell script, and then you'll get this view in front of your cursor to indicate that this terminal is appropriately set up for the Baxter environment. The next thing we need to do is ROS launch the Baxter Gazebo file. So Baxter has a Baxter Gazebo package, and within that we have a Baxter World launch file that you can run. Now this launch file will take about 30 seconds to properly load, so you'll need to be patient. As this launch file is running, the first thing it'll do is open a window that simulates some of the buttons on the robot interface. We won't be using this much, but this error occurred because I ran my shell script without the simulation parameter, so it's expecting to connect with the real robot. I apologize about that. So let's try that one more time. So here is that simulation window that allows you to simulate the clicking on all the buttons on the Baxter robot arm. Then Gazebo will slowly open up. What we're doing here is loading all the controllers, position controllers, joint controllers, velocity controllers, and effort controllers for the robot, and then actually starting the position ones. As we wait for that to load up. Oh, look, I have a black screen for Gazebo. Sometimes that may happen to you. If it does, you'll need to run the script just one more time. There we go. So you'll see that Baxter starts with his arms swinging since the controllers are not yet turned on. You can click on the belly of the robot or the torso of the robot and then use your mouse commands to bring it forward. Your first impression will be that the simulation is a high fidelity simulation with a great look for the robot. You'll know that the entire simulation has been properly loaded when the last message in the terminal says gravity compensation was turned off. And on the Rethink Robotics website, you'll find many basic demos that you can try at this link. This will be part of your homework for today. Let me show you just one of them, which is the joint velocity wobbler. It'll move all the arm joints with sign varying velocities. So I can just open a terminal here. Anytime that I open a terminal, I need to rerun the Baxter shell script in simulation mode. And so we're ready to run Baxter examples joint velocity wobbler. When we run the script in this way, it'll enable both of the robot arms and then run the velocity wobbler on both of those arms. So you can see this kind of wobble, but just in the joints of the arm. A couple of more examples are how to enable the robot. Sometimes the robot is in disabled mode, and just to get it going, we need to enable the robot. This script will also disable or do other things, but the focus will be to enable. As part of Rethink Robotics API, please see the link right here, we have a Baxter Tools package with the script enable robot. The way we run the argument, the enabling is by saying run Baxter Tools enable robot.py, and then the argument, which in this case for enable would be -e. So if we go back to this window and I want to enable, I might say run Baxter Tools enable robot.py enable. The velocity wobbler that we ran earlier, for example, includes this command within the code. So we didn't have to run it earlier, but sometimes you'll need to do this in order to get the robot going. Another example might be the robot tucker script, where it tucks the arms of the robot. This is useful when you need to pack the robot or move it. This is just as an illustrative example, And so here we run the Baxter Tools tuck arms.py -argument, U for untucking and T for tucking. When we run the tucking script, collision avoidance in the robot is disabled. So it asks you to be careful when you run the script. All of these scripts will run exactly the same in the real robot compared to the simulated robot. So if this is the first time you're looking at it, you might feel like this is pretty cool. It's very nice to see a full-sized robot model like this one working so well in simulation. Okay, that's all for the introduction. Then in 14.2 and beyond, we'll move into some specifics.